Okay, substitution is one of those topics that you have had a good deal of experience with. If we have a problem like a plus 3 equals 7, and then we say a is 4, you guys are very comfortable with replacing that a with 4 and writing 4 plus 3 is 7. So what we're going to be doing now, and we did a lot of substitution with our proofs. We would have things like, angle A plus angle B equals 180, and we would have angle A plus angle C equals 180. And because they equaled each other, we could write by substitution that angle A plus angle B is equal to angle A plus angle C. Those are places you've used substitution before. Now we are going to keep using this idea. We're actually going to go back to that solving systems like we did for graphing. So solving systems of equalities with substitution. Why are we even doing this? We are going to find that point, that ordered pair where two lines cross, that solution to the system, like we did with graphing. Except this is better because substitution is exact. In the graphing homework, all of your ordered pairs worked out to be nice, even, whole numbers. But that isn't the real world. If you have decimals or fractions, it's hard. You end up estimating those on a graph. And so substitution gives you the answer exactly because it's algebraic. So we have a 6-step process. Solve one of the equations for one of the variables. They might already be solved for x or y, and then you can skip this step. If they're not, choose the easiest one and solve for it. 2, replace this new solved expression for the variable in the other equation. You're going to substitute in. Solve for the remaining variable. Take that answer, go back to one of your original equations, substitute it in, find the other variable. Your answer should be an ordered pair. Don't combine them. You're going to have an x answer and a y answer. And you can check them by substituting them back into both equations to make sure they work. So let's look at how this goes. It sounds more complicated than it is. Now this first example is the best kind of example to get because they are both already solved for y. So what that means is that these two things are equal if they both equal y. So I can write 5x minus 2 as my first step equals 5x minus 4. So solve. If I subtract 5x from both sides, I end up with negative 2 equals negative 4. And that can't ever, ever happen. And so this is no solution. If you remember when we graphed, that sometimes we would get no solution, and we would get no solution when our lines were parallel, like these are. When you're solving by substitution, if you come up with a statement that is false and always false, it's no solution. If you got down here and you came up with a solution that was always true, like 5 equals 5, then what you're talking about there is infinite solutions. All real numbers because they're really the same lines. So those are your two options there. Now let's look at this example over here. This one is already solved, so y and x minus 3 are the exact same thing. Be very, very careful with your parentheses. So what I can do is wherever there's a y in this first equation, I can replace it with x minus 3. So my first step is to say 3x plus x minus 3 equals 1. So I replaced this y with this one. Now I can go ahead and combine like terms. I have 4x minus 3 equals 1. Add 3 to both sides. Divide by 4. X is 1. Now my second step is to take x equals 1 and go back to either one of these two equations. Doesn't matter. replace the x with 1, and solve. Now the second one is a little easier to use. So I'm going to write y equals 1 minus 3. Now what I've done here is I have taken this value and that value, and I've replaced it. And what I get is y is negative 2. And those are my answers. Now if you took and went back and checked and put 1 in and negative 2 in, your answers should work out. 2 more examples. I have another one here, this top one, that is already solved for y. So wherever there's a y, I'm going to insert that. My first step. 4x minus 4, watch your parentheses, negative 8x minus 11 equals 8. Distributive property. Watch that negative, so I have 4x plus positive 32x plus 44 equals 8. Combine like terms, 36x plus 44 equals 8. Subtract 44 from both sides. 36x is equal to negative 36, and x is equal to negative 1. Step 2 is use this x equals negative 1 in either one of those two equations. Again, this one is easier because there's less algebra involved. So I replace the x with negative 1, and I have y is equal to 8 minus 11, and y is negative 3. And those are the answers. Now, this example requires some extra work because neither one of these two is solved or ready for substitution. When I evaluate these two, this top one is going to be much easier to solve for y because I don't have to do any division. I can just subtract away and get y all by itself. Take the path of least resistance, solve for the easiest variable. You could solve for x in that top one and divide by 8 and have a fraction, and that would be fine, but avoid it if you can. So I'm going to subtract 8x, and so my first step here is to write this as y is equal to negative 8x plus 23. Now, wherever there's a y in the second one, make sure you switch. In the second one, you're going to replace it with this. So I've got negative 8x plus 3 times negative 8x plus 23 is equal to 5. You don't always have to solve for x. You could solve and substitute for y. These problems have just worked out that way. So I'm going to have a distributive property here. Negative 8x plus negative 24x plus 69 equals 5. Combine like terms. Negative 32x plus 69 equals 5. Subtract 69 from both sides. 32x is equal to negative 64. Divide by 32. X is positive 2. Then your third step is to take that x equals 2 back into either one. Again, I'm going to go with the top one because it's simpler algebraically. And I'm going to have 8 times 2 plus y equals 23. 16 plus y equals 23. And y is equal to 7. So the ordered pair 2, 7 is where this thing, these two lines, intersect each other. Now, I'm sorry, word problems are another part of this. So we're going to read the question, we're going to define the variables, write our two equations, and then solve using substitution and check by using substitution and or common sense. Again, negative answers may not make sense. So we are on a submarine tour that passes a group of scuba divers and octopi. Yes, that is the correct octopi. You count 27 heads and 126 legs. How many divers and how many octopi are there? So, variables. We're going to let D be our number of divers. And we can't use O because it's confusing, so let's use P equals the number of octopi. Now this is kind of a silly problem because it doesn't directly tell me, but usually there's going to be a total quantity problem and then I call them weighted quantity. 27 heads is my quantity because last time I checked, divers and octopi each only had one head. So that tells me that the divers plus the octopi in total have to be 27. Maybe there's 20 divers and 7 octopi. Maybe it's the other way around. Now, the 126 gives me the weighted choices. Divers have 2 legs each. Octopi have 8 legs each, and that together have to be 126. Now I have a system of equations that can be solved. So the first thing I have to do is probably solve this one for one of my 2 variables. Doesn't matter which one. I'm going to say d is equal to 27 minus p. Now I can do my substitution. Wherever there's a d, right here, I'm going to replace with 27p. All right, so now I'm going to do my substitution. 2 times 27 minus p plus 8p equals 126. Distributive property, 54 minus 2p plus 8p equals 126. Combine like terms. Oops, 64 plus 6p equals 126. Subtract 54 from both sides. 6p equals 72, and p equals 6 divided, or 72 divided by 6 is 12. Now this is a great example of where you wouldn't want to get a fractional answer because hopefully we don't have parts of animals. Now that we know we have 12 octopi, we go back to our original d plus 12 equals 27. Subtract 12 from both sides, and d is 15. So what we have is we have 15 divers, and we have 12 octopi. And that is how you work word problems.